Today our lesson is just on one-step equations. So this is just like the very basic beginning of solving equations, and we're just going to go over some of the terminologies and some of the inverse operations. So the vocabulary that we're going to be really focusing on is these inverse operations here. And inverse operations are two operations that undo each other, such as addition and subtraction, or multiplication and division, or even squaring and square rooting. Equivalent equations are equations that have the same solution. So whenever we do things to equations, the whole theory that when we do something to one side, we need to do it to the other side, that's in order to keep the equivalent equations. So some of the properties of equality that are very commonly used here are the addition property of equality, where we add the same number to both sides of an equation to keep that equivalent equation. To subtract, the subtraction property of equality, where we subtract the same number from each side of an equation, still producing an equivalent equation. The multiplication property of equality, where we multiply each side of an equation by the same non-zero number, and that will produce an equivalent equation. Or the division property of equality, where we divide each side of an equation by the same non-zero number, and that will also produce an equivalent equation. Now again, just take note that the multiplying and dividing requires any number other than zero, because when you multiply by zero, that just will turn everything into zero, and then that really won't help you. So the first example, we're going to just go over how to use subtraction. So if your original problem here has x plus 11, to move this 11 to the other side of the equation in order to get the x by itself, we would need to do the inverse property of addition, which in this case would be subtraction. So we would subtract 11 from either side, leaving us with x equals 4. Now, as always, you can check any solution by simply taking your answer, substituting it back into the original. You could do this in your head or on your calculator just to make sure you got the correct answer. So 4 plus 11 does equal 15, so that's a good answer there. Now, example 2, we're going to solve the equation using the addition property. So in this case, we have our problem, x minus 8 equals 17, and we would want to add 8 to both sides. And I wanted to show you two different formats you can use to do this, and you could do this also for subtraction. But typically, we've always used this vertical format where we kind of add the 8 underneath so we can cancel them, and then we add the 8 underneath the 17. And that's nice because then if you need to add or subtract, you already kind of have the numbers stacked on top of each other. It's a little bit easier to do your addition or subtraction, especially if you don't have a calculator. Now, if you're doing things on a computer or something like that where you don't necessarily have the ability to stack things underneath, you can certainly add 8 to each side and keep it written horizontally. And you're still going to get the same result because if you have a negative 8 and a positive 8, obviously those are going to cancel. And then on the other side, you would just combine those like terms, adding them up, and you would still get the same answer, 25. So again, it's just two different methods you can use to organize your work. I prefer the vertical format on paper, but if I were doing it digitally and I had to type in my work on a computer or something, then I would probably use the horizontal format. So just practicing a few examples here. So we can notice number 1 is x plus 9. So the inverse operation there would be to do the subtraction property, which would leave me with x equals negative 4. Number 2, again, another addition problem. So I'm going to use that subtraction property. Negative 5 minus 2 is negative 7. And then over here, just because the variable's on the right, we still want to get the variable by itself. So we're going to subtract the 13. And then we're left with the w equals 6. Now, it doesn't matter which side of the equation the variable is on, which side the answer is on. So if you prefer to write it in this order, that's fine. Now, the next 3 problems are subtraction. So we're going to use the addition property of equality to get rid of that number or to move it away from the variable. So I'm adding 11 on both sides to keep my equivalent equation. This gives me a 19 equals z, or if you prefer, you could write z equals 19. Number 5, using my addition property to get the m by itself, and m equals 10. And then for number 6, using the addition property once more, negative 12 plus 4 would leave me with a negative 8. Moving down to example 3, we're going to solve an equation using division property. So this property is used when you have an equation where you have a coefficient next to your x, or a number being multiplied to your x. And of course, the opposite of multiplying is dividing, so that would be our inverse operation here. Now 7 divided by 7 is really a 1, so you're technically getting a 1x there, and negative 63 divided by 7 is negative 9. Now, in algebra, we typically don't worry about putting a 1 in front of a variable. So if a variable's, 1x or 1y or something, it's just kind of implied if we just write the variable by itself. So in this case, our answer would just be x equals negative 9. Again, you can still check your work by plugging into that original problem. And finally, solving an equation using the multiplication property would be used when we have a division problem. So here we have x divided by 12 equals 4. My inverse operation would be to multiply, and so we would want to multiply by that denominator there. That leaves me with an x equals, and then 4 times 12 is 48. It's also referred to commonly as multiplying by the reciprocal, which actually comes into play when you have a full fraction, like I will show you in example 5. In example 5, the coefficient of x is 3/5. So it's kind of like saying 3/5 times x, which leads most people to think, well, then I'm going to divide by 3/5. Now, that's fine. Technically, you are dividing by 3/5, but how do we divide fractions? So think about this. If you had, for example, 1/2 divided by 3/5, how would you solve that without a calculator? Well, you would have to leave your first fraction, the 1/2, the way it is, change your sign to multiplication from division, and flip your second fraction. Then you could multiply across the top, which would be 5, multiply across the bottom, which would be 6, and you would get your answer. So if we're dividing by 3/5 here, we're really multiplying each side by the reciprocal. So there's no sense in writing down divided by 3/5 because it's not useful to you. You have to then multiply by the reciprocal. So typically we just forget about that part right there, and we just right away from the get-go multiply by the reciprocal. Now, when you do that, you're going to end up with x equals, and over here, 6 times 5 is 30 over 3, and that would simplify to 10. Now, another option for simplifying anytime you're multiplying fractions is if you happen to notice that one of the numbers on the top and one of the numbers on the bottom can be reduced or simplified, it's best to do it in the beginning because then the numbers that you're multiplying are smaller. So 3 goes into 3 one time, 3 goes into 6 twice, and then I could have just done 2 times 5 and got my final answer of 10. Okay, so number 7, we're going to use the division property here, dividing by a negative 9. So just make sure whatever sign is on that number stays with it. Negative divided by negative is a positive 4 here. Number 8, we're going to divide by 7, leaving us with y equals 3. Now number 9 is a division problem, so I'm going to multiply by that 3 on both sides, leaving me with x equals, and I believe that that's 72, and of course it's a negative 72. Number 10, once again, we have a division problem here, so I'm going to use my multiplication property, but because I'm dividing by negative 2, I'm going to multiply by negative 2 on both sides. So negative 2 times 18 is negative 36. All right, now 11 and 12 are the problems with the reciprocal, right? Because if I were to divide 2/5 z by 2/5, that's not going to be very useful. So I'm going to have to multiply by the reciprocal, which is 5 over 2. All right, now on this side, of course, they cancel. That was the whole point of it. Now over here, we have 8 times 5, which is 40. And technically, this is over a 1. So 1 times 2 is 2 on the bottom. So you could do 40 over 2. But of course, then you would need to simplify that to 20. Now again, I recommend, since I know that 8 and 2 could have reduced before I did that multiplication, 2 goes into 2 once, 2 goes into 8 4 times, and then I could have just done 4 times 5 and got the 20 that way. Okay, and then finally number 12, I'm going to again multiply by that reciprocal, which is 7 over 4. So on the side with the variable now, I'm left with just that m all by itself. And on the other side, I could do 7 times 16 and put that over a 4, but I don't really feel like doing 7 times 16 in my head, so I'm going to simplify this because I know 4 goes into 4 once and 4 goes into 16 4 times, and it's much easier for me to multiply in my head 7 times 4 and then get that 28